Hey guys, welcome back. In today's deck, what we're going to do is talk about static electricity and particularly how charges travel from one thing to another. And we're also going to bring up a thing called an electroscope, which is a pretty cool little tool for studying that. So to begin with, I've got a picture here on the left of our Phys2H, which is one of our science companies that we buy from, Electroscope. And it's got some slick features. It's got a little metal ball up the top. It's got a metal hoop here that forms the body of the thing. It's got this central bracket in silver that you see in the photo. And then it's got this central needle. The key thing about the whole apparatus is that the bracket and then the needle are in electrical contact with each other, but they're isolated from everything else because they hang from a little insulator up here that doesn't allow charge. Well, I take it back. Charges can flow from the knob on down to this thing, but the charges are not shared with the hoop or the base or the ground. So what we do is when we charge this guy by putting charge on this ball, that charge will travel through to the bracket and it'll get shared. Okay, so long story short, what we've got here is a picture of an electroscope that shows it indicating charge. And how does it work really? Well, let's just say we wipe some positive charge, if that was possible. Really, the way that works is we're stealing electrons from the thing, but we charge this guy positive. Then what will happen is that positive charge will travel to the bracket, it'll travel to the needle, and what will happen is because the needle's on a pivot, it'll create this tendency to rotate. Okay, same thing down here on the bottom, positive charges extra here and here, and you get the same tendency. So the needle will tend to rotate like that, and you get a pivoting motion that indicates charge. Okay, so the first type of charging we wanted to talk about is charging by friction, also called triboelectric charging. And there's a thing that I've given you here on the left that you don't need to memorize, but it's the triboelectric series. The bottom line is that some things, when they come in contact with other things, want the electrons on the outer shell of the materials they're rubbing on more than the other thing that they're rubbing against. So what's a really good taker of electrons? There's a black plastic called ebonite that they have as the kingpin. But we've got polyvinyl chloride, which you'll see us use in our demo. PVC pipe is pretty good at doing these demos. And if I was trying to, say, for example, get a static charge by rubbing, I don't know, like wool and glass together, I wouldn't have much success. Not because they're both positive, but because they're really close to each other on this series. So I'm not going to get much effect if I were to rub wool and glass together. Really, you get the best effect is if you pick things like a strong taker of electrons over here and a strong giver of electrons over there. Anyway, a couple quick things. A mean thing to do is to sneak up on a sleepy toddler and rub their head with a balloon, but it works, right? And you can see that charge has been conserved. So a key principle here is that charges are neither created nor destroyed. What happens is they just move. And in real life, it's always electrons that move, almost always. And what's gone on here is the balloon made of plastic has probably stolen electrons from this little girl's head. And so little girl's left positive, but what's cool is you can see a connection between the two of these things where they're oppositely charged and attracting each other now. One version of that's actually really serious is that where you can scuff your feet in a rug and it's kind of funny to shock your friend, a truck rolling down the highway does the same thing. And if that truck's a gasoline truck, you don't want the first connection to ground to be where the guy who's filling the tanks in the underneath the ground of the gas station connects a metal fitting on the truck to a metal fitting on the gas tank. It can be deadly. It could explode the gas. So I don't know if you can see it in the photo, but there's an image right in here where we've got this chain hanging on the ground. There's another chain here hanging on the ground. Some trucks use those. Some trucks actually have metal braids that just drag on the ground all the time, so the truck never becomes charged. And still other trucks have a plug-in system that they use that they can plug into at the gas station. Anyway, so triboelectric series, triboelectric charging, and charging by friction. Real quick, two other modes of charging. Charging by conduction is what we always think of as the prototypical kind of charging. So what's going on here is I have an uncharged electroscope. So for every plus inside of the scope, there's a minus somewhere else. And what's gone on here is, let's just say we've dumped a whole lot of minuses on here. and I've got extra minuses everywhere, and so the electroscope registers a charge. Literally, it's that simple. If you take an object that's negative and wipe it on this thing, then negative charges can hop off from, say, it's a PVC pipe maybe. It's full of extra negatives, and if you can get the negatives to jump off, then by conduction, when these two things touch each other, that's what will happen. Okay, finally, a little fancier version of that. It's charging by induction, where there's a very interesting middle step. So here's my uncharged capacitor. I've got equal pluses and minuses on this guy. And here is my charged capacitor. The way we're going to get this to happen is we'll bring up a charged object near, but not touching. So let's bring back my negative PVC and bring it close. And what will happen is charges will migrate because electric fields will reach out between them, which we'll study later. But what you need to think about is just that negative charges inside of this, because it's made of metal from the dome to the bracket to the needle, the electrons in there are free to move. And so when they see electrons in the PVC coming, they will tend to congregate down here. And then we'll register what looks like a charge on this. This object's not actually charged. For every negative up here, there's an unaccompanied positive up here. And so again, this guy registers a charge, but it's not really charged. What happens, you'll see in our demo, is you come along and you simply touch this knob at the top, and you alleviate the local clustering of positive charges here by dumping some minuses on to this needle from your finger. And what then happens is you've charged the object by induction. Okay, so that's 3 kinds of charging. Check out our demo, and we'll see you later. Thanks a lot. Bye-bye. Okay, so I think we've got a pretty cool little demo here for you. This is our electroscope that we've talked about. I've got my grounding wire right here that's connected to the third plug where you plug in stuff in the lab. And the first thing I wanted to do was to give you an example of electricity or charging by friction, triboelectricity. I've got a piece of red wool, I've got a piece of glass, and we're going to scuff those. And we're going to use our electroscope to see if we are able to get any charge on that glass. And we didn't. And how about on the wool? And we didn't. And this is one of the biggest issues that you really run into in real life with electrostatics, is that when you're making a video in September, there's a lot of humidity in the air. There actually is outside today. I'm not going to turn the camera on, but it's gray out there. And so what happens is you have to go with some things that have bigger separation on the triboelectric series. Some things like rabbit fur. Rabbit fur is a pretty good giver of electrons. PVC. This guy from Home Depot. It's a plumbing fitting. And if I scuff those, PVC is a better taker of electrons than glass is. So if I scuff those, scuff it vigorously, and we'll see if I did it right, then we should get a little bit of attraction where you should see the fur trying to follow. Oh, look at that, the fur is even moving a little bit. Trying to follow the PVC. Okay, so they're oppositely charged. This guy stole electrons from this one, charging by friction. What we're going to try to do is see if we've got enough charge on here to show you charging by conduction. So charging by conduction is really simple. I'm just going to wipe this guy onto the electroscope, and what a letdown. So there could be, well, it's a little bit, but that's a letdown. So there's 2 things that are going on. Charges or water molecules in the air are great at stealing charges from real-life objects. And PVC honestly holds on, because it's an insulator, holds on to its charges pretty well. So, okay, that's better. So we did get some charge by conduction from that one. Not bad at all. Okay, so what happened was we're able to get electrons that were extra on the PVC to jump onto the electroscope through the knob, and they ran down, as we talked about, down to the central bar and the pivot, and the needle is now showing you that we've got some charge because we've got repulsion going on. Okay, great, charge by conduction. So how do I get this guy to go back? I could wait. Air molecules will bounce onto this thing, and you may even see it happen before your eyes if I wait long enough, but we're not going to take up your time with the video. You can see it slowly losing charge, but I'm going to touch this knob right here. Now I'm not strictly grounding it because I'm not anchored to the planet. I've got rubber shoes on and I'm in a lab. But I'm a big enough reservoir that I can probably soak up those charges and it'll go away. If I really want to make sure I've done a good job, I'll plug it into the wall. Hey now, there's an issue of relative ground that just happened there. Interestingly, yeah, the floor and me were all charged up. That's a story for a different day. Grounding is an interesting idea. But now it's truly grounded. I've plugged it in, touched it. We're all literally at 0 volts. But to do the next thing, I want to show you charging by induction. And to do that, I want to bring up a more heavy-duty piece of PVC. So here's one we use for the sound demo. Yeah, it's like a couple feet long, and it's, what is it, like 2 inches wide? So if I scuff this guy up, you may be able to actually hear the sparking happen as I pull electrons off of the rubber first. Let's give it a try. Hopefully you could hear that. Okay, finally. Take this PVC pipe. Let's do charging by induction. First step, let's make some polarization happen. I'm not touching the electroscope. Pull the PVC pipe back. It's not charged. The scope is not charged. The scope is telling you it's charged, but it's not charged. If I pull that guy away, he's not charged. So what I've done is induce polarization. Polarization is where the charges separate again. So let's do that one more time. Induce some polarization where I chase the negatives inside the central silver bracket down to the bottom. Now I come up and I do the trick where you get charging. Touch this guy, and he goes crazy. So what have I done? Hey, one more time, come on. There we go. What have I done? Let's follow it. So when I polarize, negative charges flow down to the bottom. That leaves relatively more positive charges on the silver knob. When I come by with my finger, I fake ground that silver knob. And so the knob has actually been tricked into taking extra negatives from my body. And now when I pull away the PVC pipe, the charges redistribute on the electroscope, and then they're left with a net negative. Okay, so that's 3 things: charging by friction, charging by conduction, charging by induction. All right, take care. See you in class. Bye.